purpose of this video is to show treadle hammer behavior in an Octagon 150-pound hammer from Iron Kiss. I have on the bottom die a saddle with a hardy hole with a dimension that's the same as the hardy hole in my manual anvil. Here is a chisel plate with a hardy stem that fits in there, and it protects the bottom die. The dies are S7 and pretty tough, but it would be not very smart to hammer without to chisel without a chisel plate. At least in my opinion. And that's what counts. It's my video. I have a piece of cold metal, unheated metal, simple A36 taken out of the scrap pile. I'm going to draw a S-shaped figure as if it was decoration on a barn hinge. I'm going to put a couple of hash marks at the midpoint, just for nice, you know, and I'm going to use a cold chisel with a bit of an arc in it. I'm going to hold that with a pair of tongs with the ability to hold square stock, round stock, octagon, hexagon. This punch happens to be octagon. This chisel happens to be octagon. In order to get treadle hammer behavior, the hammer is put into single blow mode, and when I hold the treadle down, it clamps whatever is between the dies. So that's clamp mode. Release the treadle, the hammer head goes up, and hence I have single blow behavior. The round edge on the chisel allows me to walk it along the chalk line. Very old technique, very useful. Now it doesn't look as if there is a great deal of force being imparted to the chisel. In fact, there is a very nice amount. The chisel line is very nice. There is a lot of pneumatic force behind that 150-pound hammerhead. The cylinder on an Octagon 150 has a 4-inch bore. The cylinder has custom-made large ports and air cushions. I get it from the Norgren factory. Norgren is the brand name of a US-made product line. Norgren is actually international, but the cylinders are made in Ohio. I made the S-shaped curve, and then half of it I made deeper with harder blows, and I stopped at this point. The depth is about twice as much as it was, so we'll continue that. So there you have the S-shaped, just for nice curve, and you could think of this as a smooth spot on a barn door hinge or some such thing. Now I'm going to put those hash marks at the halfway point. There you have it. I'd like to talk a little bit about the tool length that I'm using. My tools are by and large the same as a machinist would use. A cold chisel, a center punch, a standard punch. There's a wide variety of tools that you can get at the flea market that come out of a machine shop or similar situation. I do also have some blacksmithing handle tools, quite a lot of them as a matter of fact, but they aren't particularly well suited for power hammer use, or even for treadle hammer use for that matter. What I do is I cut the shanks to 3 to 4 inches in length, and I try to keep them equal in length. I'm imperfect about that, but as long as you're close, you have the same basic notion of how to position the hammer and how to move the treadle. With a use of a blacksmithing handled tool under the power hammer and treadle hammer mode, you can do it. This one is about as tall as I would like to use under a power hammer. This tall old chisel is not an appropriate length. It is oh so easy to get out of vertical with it, and once you get away from the top die, you're going to knock it over, and it could come as a rude shock, and you could really hurt your work in progress, and you know, you can hurt yourself if you don't pay attention. Here's an example of a very short tool. It's a setting off tool or bulldozer tool, call it what you will. It's a rectangle with rounded edges. Commonly used. It's very commonly used in reciprocation mode. And I'm going to demonstrate use of a handled chisel in reciprocation mode. The dilemma with reciprocation mode is you get a bounce in the tool, and here I nicked the metal where the chisel bounced out, and I flinched. And where I was chiseling is kind of crude now. So I don't like reciprocation mode for doing punch and chisel work. A bulldozer, of course, it helps with drawing out. The 150 is an extremely gentle machine when you want gentleness. The treadle hammer mode of behavior is perfect for that. It is adjustable in terms of air pressure, it is adjustable in terms of hammer speed, it is adjustable in terms of airspace, stroke length, and it is adjustable according to the inflow of air. It's adjustable according to where you put the treadle down. It's an amazingly adjustable hammer that you can set up to do gentle work or really brutish hard work if you're hammering out 3-inch billets or something. So it is perfect for that shop where you do a wide variety of work, from big heavy stuff to light stuff like hinges. The dies are S7. They're 6.5 inches long. They're the biggest dies that Brian Russell makes for power hammers. You can make an amazing variety of spring fuller tools to fit in a bottom die saddle, and with totally flat dies, you can move that chisel or punch up and down 6.5 inches of length and get quite a lot of work done in a very short period of time. Here, I was trying to stay within 3¼ inches of the flat part of the combination dies. Once you get into the rounded part of the fullering dies on half and half dies, the chisel can slip away from you, and that becomes dangerous. So there you have it. It's a wonderful hammer. It's had this treadle hammer capability for about 1.5 years. Before that, I hadn't thought of how best to do it, and now it's there. It's essentially like a steam hammer.